Okay, this lesson is about insulin and glucagon, and so what happens to our body when we intake some sugar and our body is trying to maintain homeostasis. So really we're looking at blood glucose levels because everything is all about traveling around in the blood, and our blood is what delivers the glucose to the different cells. So our levels of blood glucose will rise and fall based on our food intake or our energy consumption. Right? We're always going to talk about food and having a meal, but really all it comes down to is the glucose, because that is what our body most needs to go through cellular respiration. So we have a look at this graph, we interpret some information off it. We've got a time frame down here, and then we've got our blood glucose concentration. So here there is a meal taken. Number one, glucose is absorbed. It's going to go up, it's going to hit quite a high point, and then our body is going to change that so it lowers. Now, unfortunately, it lowers past an appropriate normal, and our body needs to rectify that again. And you can see there are two hormones involved here. We've got the insulin and we've got glucagon, and they both work. They work in opposite directions there. Okay, our two hormones, insulin and glucagon, are both produced in the alpha and beta cells in the pancreas, right? So in the islets of Langerhans. And the alpha cells are secreting the glucagon and the beta cells are secreting the insulin. You need to be very careful. Glucagon is the hormone, right? We often mix that up with glucose or the word, I've forgotten the word, that's really good. All right, so we'll move on. Okay, insulin is there to assist in cellular uptake of glucose. And what that means is that when you have a meal, your body needs to intake the glucose by storing it away in cells. Okay, we may not need it immediately. You've heard of a sugar high, maybe you've got sugar that is easily intaken into cells and you get a little bit hyperactive. And the flip side of that is looking at, say, low GI foods that you can have that sugar, but it will slowly work across the day. So what happens is our intestines are absorbing the glucose after a meal. It's not just going to come straight from your mouth, though it can be broken down all the way through. It can even be broken down in your mouth from your salivary glands. And the glucose level increases, and your body will notice, and the pancreas starts pumping out that insulin. That insulin is there to help store it away. And not only will it store it away in cells that need it, say your muscle cells, but it might also store some away for later on. Okay, and your liver is a really big storage place for that. So they've actually got a picture of a liver here, but we can also see its liver, skeletal muscle, and other tissues that take up that sugar. Homeostasis, it says that is then restored, but it's never quite that simple. We know that that level can go up and down and up and down. Insulin is there to open up these gates to allow the floodgates over here to open. So if this is our cell membrane, the insulin receptors, so the receptors receiving that chemical signal, once one of these chemical messengers has bonded, it actually says, signal transduction. It will send that message across and allow those proteins on the outside of the cell, transmembrane proteins there, to open up and allow some glucose in. All right. Obviously, this may take energy. It is not a passive process, but it still needs this insulin to facilitate the process and to be the stimulus for that signal transduction, and therefore the response being that glucose is intaken. Glucagon, on the flip side, is doing the opposite, and it breaks down stored glycogen, there's the word we need to think about, to increase blood glucose. Now, glycogen is a form of stored glucose. So if we flick back here to the insulin, once this glucose is stored, say, in the liver, and it's not being used immediately, it is stored as a longer chain carbohydrate called glycogen. Now, glucagon works to release the glycogen from, say, that storage, and we can see it's stored in the liver. It can also be stored in fat cells and skeletal muscle. So it's not actually stored in skeletal muscle, so glucagon will have no effect. As soon as skeletal muscle gets that glucose, it will use it because they are high energy needs types of cells. But if we have the sugar stored as glycogen in the liver and our blood sugar levels start to drop, we're getting towards a meal, you're starting to feel your stomach rumble, you're starting to get a bit lightheaded, that's when your body goes, okay, release the glucagon, and the glucagon can then release the glycogen and push our levels of sugar back up into the blood. Homeostasis works as a negative feedback loop here. okay? It's going to keep going up and down, up and down. It's never, ever going to be perfectly just right. It's always going to be sugars being used or sugars needed. So too much sugar in the bloodstream we call hyperglycemia, and hypo is the flip side of that. So if you talk about a diabetic person having a hypo, it means their blood sugar is very low, versus, say, giving a kid a bright red cordial and having hyperglycemia. Suddenly they are hyper, and their insulin levels will then need to act to lower the sugar. Okay, if they have a high sugar meal, their insulin levels will suddenly try and react. The flip side of that is, if suddenly I'm coming up to lunch, I'm really, really hungry, then my insulin levels aren't going to do anything because there's no sugar for them to start to store. So the flip side is we need to have that glucagon releasing the sugar. Right, so there's our negative feedback loop. Quite complicated there. And we see we actually have a normal range here of what it should be, approximately 90 milligrams of sugar per 100 ml of blood there. And so if you're trying to monitor your blood sugar levels, you would obviously need to keep monitoring via your peripheral blood. So you might do a finger prick test or something like that. Diabetes is a problem if you are unable to regulate the levels of blood sugar that you have. So we have two types. Type 1 is about poor insulin production. Right? You cannot make insulin anymore from your beta cells in your pancreas. And it's often called insulin dependent because those people need to supplement their body with insulin. They need to intake it. They might need to jab themselves. They might have a pump that pumps it into them depending on how much they need at the time. Often it is early onset. You'll see it in juvenile people, so teenagers is often where it is diagnosed, and you have deficient beta cells, right? Often it is because of an autoimmune reaction, which means your body turns its antibodies on your beta cells. So it's turning it on itself, saying, hey, this shouldn't be there, when in actual fact you do need those beta cells. The flip side of that is type 2, and type 2 is about poor insulin response. It is not about not being able to produce insulin, it's about not being able to respond to it. So your body can still make insulin, but those receptors don't do anything when they see it. So it's often called insulin resistant because your body is exactly that. It is resistant to insulin. This is our lifestyle diabetes, our type 2, generally over 40. The receptors become desensitized. So if you think about someone with a terrible lifestyle, you're eating a lot of stuff, you've got a lot of high blood sugar all the time, your body is trying to counteract that by pushing out a lot of insulin, and eventually those receptors just go, no, we see you all the time, we're not going to react to you. And that's what we talk about when we say desensitized. So the body starts to use fats as an energy source instead, which sounds good but isn't actually good in this case because it does change your blood chemistry and it makes it more acidic. So you get something called diabetic ketoacidosis, and it's not good for you at all. Memes. All right, high levels of blood glucose cause a lot of damage in nerves and blood vessels, and diabetes is one of the hugest problems that people see and end up in hospital, and it's complications due to diabetes, not just the diabetes, but unmanaged diabetes. The increased use of fat metabolism leads to more of it in the blood, and that can lead to atherosclerosis, or the hardening of the arteries because of all the buildup of the fatty stuff inside those blood vessels. You diagnose diabetes through glucose levels in your blood and urine, and later on when we talk about the kidneys, we know that you cannot, or you should not be putting out any glucose. Your body needs that so much to make energy. So if you are removing glucose via your urine, something's gone wrong, right? That means you've got way too much of it, and that means your body is not intaking it into your cells. So many complications with diabetes, so many, all right? Stroke is one because you're starting to get the thickening of the blood because there's so much sugar in it. You get a lot of retinopathy, so a lot of problems with your eyes. Renal disease, absolutely. Your body is trying to filter out things that it needs and things that it doesn't, and you're not really providing it with an appropriate bloodstream to sort that out. It makes it really difficult. Neuropathy means that we're having problems, and feet problems, absolutely, with our nerves that go all the way to the end. Peripheral vascular disease, so out in our limbs, we start getting problems with our blood vessels, and absolutely the heart disease and hypertension, which we spoke about before. Some pretty gross pictures there. Ulceration on the foot, because our peripheral circulation, so all the way to the ends of our tips of our toes and feet, starts to struggle, these things start not to be able to heal. Your blood starts to not be able to clot. And there's our retinopathy. We start to have problems with seeing and cataracts. Now, nerve damage, being able to clear, so the vascular damage, being able to clear that blood and that excess fluid becomes a bit of a problem. Okay. So diabetes is a huge problem in particularly obese populations, and that's what's happening in Australia quite a bit at the moment. And it is causing huge amounts of stress and strain on the health system.